Hello, welcome back. We're going to continue our discussion on volume of revolutions about an axis. And again, we are talking about the area that's going to be between two curves. So for example, in number 3, we want to find the volume of the solid of revolution generated by revolving the region about the parabola negative x squared plus 4, the line 2x plus 1, and x equals 0 about the x-axis. This is very nice because we're about the x-axis, so we are in terms of x. This is nice, which means we're looking at a vertical. This looks terrible there. We are about a vertical rectangle. All right, so let's go ahead and take a look. So we're looking at the parabola y equals negative x squared plus 4. So that's this one right over here in red. That's this one. The line y equals 2x plus 1, so there's our line. And x equals 0, which is the y-axis. So we're looking about the region that's bounded by all three of those, and that's this region in here. We're going to revolve this about the x-axis. So to do this, notice I'm looking at this region and I want to measure to the x-axis. If I were to draw my first rectangle, remember we draw a radius. If I want to go up to the very first one, I have all this blank space, this hole. So this is going to be our washer method. And for the washer method, we are looking at two rectangles. So there is my first rectangle, of course. There's my first rectangle. So if I draw that, there's the x-axis. To get the radius of that first one, this would be like the radius of our outside. To get that radius, we would take the top function, which is a parabola, minus the very bottom of that rectangle, which is our axis of revolution, always, x equals 0. So this is going to give us negative x squared plus 4 minus 0. The height or the thickness is going to be dx. That's just like right here, that's our height. So my radius is just going to be negative x, whoops, let me rewrite that again here. It's just going to be this negative x squared plus 4. So there's our radius and there's our height. Now we also have to get the radius of the inside. Now that's this inner part here. So that's the hole right there. So that goes to the other function. So again, measuring from our axis of revolution, we're going to measure straight up until we get to our bottom function or inside function. And that's going to be another disk right here. There's the x-axis. To get the radius, it's going to be the outside the top function. The top minus the bottom. Well, the top is our line this time. Y equals 2x plus 1 minus the bottom, which is again the axis of revolution. Remember, this is always going to be the axis of revolution. So when we go top minus bottom here, the bottom is always our axis of revolution, where the top is our function. The thickness, how wide it is, well, that's how wide our rectangle of mathematics here is. That's just dx again. That's always going to be dx, so there's our height. So our radius is just 2x plus 1, and the height. So to get the volume, remember, we're going to do volume of the outside minus volume of the inside, and that's it. So we would get pi. We can go ahead and write this out. Our outside radius squared, because remember, v equals pi r squared h. So our outside radius, remember, is this negative x squared plus 4. So we get negative x squared plus 4 squared minus the inside radius squared, which is this 2x plus 1 squared, and dx. That's our height. There's our height. And we do have one more step here where we have to do. We do have to find our bounds. So let's go ahead and get the bounds here. To get the bound, we just have to find out where the two meet. We know we're starting at 0. We just have to find out where they meet. So we're just going to take this negative x squared plus 4, set that equal to 2x plus 1, and I'm going to bring my x squared over. X squared plus 2x minus 3 equals 0. Factor this, x, what's that? Plus 3 x minus 1 equals 0. And we get two answers, -3 and 1. But remember, we only want the one in the first quadrant, so we don't want that -3. So we can just kind of scratch this one out. We only look at the 1. So we would go from 0 to 1. And there is our integral. And this actually goes really quickly. Remember, the only thing you really want to remember when we're solving these type of questions is that we're winding up with a disk on the outside, but we're also revolving this inner disk right here. And just like we said at the beginning, this is very much related. In my first video, it's very much related to what we did with the areas between two circles. We have to find the area of the outside and subtract the area of the inside. And that's the very same thing we did down here. Sorry if I got you nervous there. We take the volume now of the outside and the volume of the inside. So we just got to take the two discs and just subtract them. Is all we're doing. All right, I hope you enjoyed the video. Go and try working some problems, and I'll see you guys later. Bye-bye.